Hi, everybody. Welcome to this webinar. So I'm particularly proud to welcome our panelists today. So everybody is almost here. We are just waiting for one more, but we're expecting that she will arrive soon. And as you have seen, the program for today will be based on four main presentations and an introduction by myself and by Leah for the IFD, one of our sponsors. And before to start, I will ask to Kevin to send a little teaser, which has been prepared by the Institut Français. Kevin, please.
My name is Ratnat Mitular. I'm the former Minister of Environment of Indonesia. When I was appointed by the President to lead the delegation to COP21, of course I'm very proud. We are very impressed that the preparations of the COP21 by the French government is very good. I'm happy to talk with you and discuss about COP21 in Paris.
Okay. So maybe Kevin will put the link for the video to have the sound if anyone wants to replay the video in the little chat question and opens. So let me to start. Okay. So I am hoping that everybody can see my screen now. If somebody can just check by the head in my colleagues panelists. Yes, okay. So the subject for today will be the marine plastic pollution. And maybe as you know, marine ecosystems around the world provide a lot of rich services. So it includes, for example, food provision for billions of people, but also cultural benefits like recreational opportunities. So as any threat on these ecosystem services will have the potential to impact the well-being of humans across the globe, owing to the loss of food security, livelihoods, and good health. So it is clear now that we need a solid understanding of the ecological, social, and economic impact of marine plastic and marine litter pollution. It's necessary to impulse a global transition in the way we make, we use, or we reuse plastic. Just to put just one number, we estimated that between 5 to 15 million metric tons of plastics enter the ocean world today. In 2010, for example, it was the estimations, the famous estimation. And we know that the flux of plastic to the ocean is predicted to increase by an order of magnitude, at least within the next decade. So over time, we also know that this plastic may fragment into small pieces, and the vast majority of this plastic will be expected to persist in our environment for a long period. So in the context of this Climate Diplomacy Week in Indonesia, we just arrived to the question that why we have to worry about the plastic litter and climate change. And in fact, if you look at a recent publication, when the plastic is degrading in the ocean or everywhere in the environment, the most commonly used plastic that we use every day as everybody in his life, we produce too many greenhouse gases. This is methane and ethylene. And methane, for example, is known to be the fourth more important greenhouse gases for the climate change, especially when we have fragmentation. And these processes, of course, will also occur in the oceans. And in the oceans, we know also like the importance of the carbon pump for the climate change, and because the ocean is absorbing CO2, but what we don't know exactly what will be the relationship between this carbon pump, which implies the biota and the phytoplankton dynamics and so on, with the microplastics. And we know that because the microplastics have the particularity to be adopted in some way by the phytoplankton and zooplankton, and it could enter the food chain at different levels and also for the sequestration of the CO2. And this is particularly an active field of research, and this is the main topic at the moment, especially if you look at a very recent publication in Nature, maybe 2 or 3 weeks ago. You can see that for the classical model of the biochemistry in a numerical model, where you have nutrients, where you have compartment for phytoplankton and so on. Now they had a dedicated or specific compartment for plastic. And the marine particle that will exchange with the zooplankton and the biota have to be parameterized or to be modelized by this type of model to be included for the prediction of what will be the climate change in the future. But before that, we have to come back on the idea that our main problem with plastic is also a pure problem of pollution. And it's why we decide to answer a project with the support of IFD, based on the monitoring and modeling of the circulation of marine debris in Indonesia. And many people today will present some results which are linked to this project that we are conducting now at the moment. And also some different work package has been addressed, and we are still working on all these aspects of the project. So I do not spend not too much time on this part, because a lot of speakers today will come back on these topics. We not cover also all, because we need some people from Toulouse, for example, which working dedicatedly to the numerical experiments, and also for the communication. It's one part of this project. So I will leave the floor now to Leah, which present before we just address the specific problem for the marine debris, a general presentation of the IFD. Oops. And just for all the people, so we have a plan to discuss at the end and answer questions. So you can address your questions in the little window question and response, and we will discuss that at the end. And please remember to mute your micro when you connect or when you stay with us. So Leah, the floor is yours. Leah, you need to demute your micro. Oops.
Sorry.
Ah.
I think it's better now. Can you hear me?
Yes. And the screen is coming back, so you can go ahead.
Thank you. Thank you very much. So I am Melalui, Project Officer for Natural Resources Management at the French Development Agency. And for this session on our ocean, I will just present to you in a few slides the experience of IFD in Indonesia. So let's start just with a small general presentation of the French Development Agency. So IFD is the bilateral international platform from French development policy. It's a major player in solidarity investment for the benefits of population in more than 100 countries. Since 2007, IFD oriented its strategy from the carbon footprint approach to the long, low carbon development trend and the consistency of the project with the commitment of each country in the Paris Agreement. So indeed, especially for the 2017-2022 period, our project has been and will be 100% Paris Agreement and 500% with climate co-benefits. We are knowing a growing activity. Since 2005, 24 billion euros have been approved by IFD in favor of climate, with an increasing trend to reach 5 billion per year by the end of 2020, including 1.2 billion euros dedicated to adaptation to climate change. So the involvement of IFD in the ASEAN region is very high. As you can see in this slide, the funding of IFD in Indonesia represents 38% of the funding dedicated to this region. Furthermore, since September, France became a development partner of ASEAN, which will permit to strengthen the relation already solid of France and IFD in this ASEAN region. So now let's dive deeper in IFD activity in Indonesia. So as you may know, being the world's largest archipelago and the sixth exclusive economic zone of the world, Indonesia conceives its development and international integration through its unique relationship with the oceans. Maybe you know that as well, but more than 6 million people in Indonesia depend on natural resources, marine resources, as an economic income. At the same time, the importance of the maritime domain makes Indonesia an important reservoir of biodiversity, but it's threatened by both human activities and the impact of climate change. So at the IFD, we are very aware of these challenges. And since 2007, we are involved in the development of Indonesia regarding several sectors like energy efficiency, urbanization and mobility, but also and especially maritime and marine sectors. Mainly our funding are made through loans with diversified modalities. So I can name project investment, I can name credit lines, I can name development policy loans and support to NGOs as well. So in particularly for this key sector of marine and maritime area, our project aims to improve the performance of the Indonesian blue economy and the sustainability of its ocean resources. So to combine in the best possible way human activities and the consideration of climate change in the maritime and marine sectors, we are financing our project, the project, always following 4 main objectives, 4 commitments that you can see on these slides, and always in close relationship with the concerned economic actors of the country. So now I will just detail you a quick review of the project we are currently supporting and under development. So let's start with the sea transport and logistics sector policy reforms. Since 2014, the Indonesian government has been working to improve the performances of sea transportation airways, improve the quality of the logistics service, and improve the clarity in terms of responsibilities in the management of the port. These efforts are supported by the World Bank as well, the KfW, and the IFD with several dedicated programs. In addition to this support, IFD, the Grand Port Maritime du Havre, and the Ministry of Transportation work together to provide capacity building to the port authorities in Indonesia. So then regarding marine meteorology, the government of Indonesia is investing to increase the capacity of its National Agency for Meteorology, Climatology and Geophysics, BMKG, in order to improve weather forecasts and climate monitoring. So this project is supported by IFD and the French Direction of General Treasury, and it will enable the implementation of a powerful meteorological system supporting all the economic activities of the maritime sectors, including maritime transport and civil aviation. This project will also be an effective tool for the prevention of natural and climatic disasters in ocean, through notably early warning systems. So another project just below, it's with the LIPI, the Indonesian Research Institute. This project finances the acquisition by the LIPI of a new research vessel and the refitting of an existing one to strengthen the actual fleet. The project will contribute to a better knowledge and management of Indonesian biodiversity and its marine resources, in order to improve the measurement of the impact of marine pollution and coastal ecosystems, but also the monitoring of the impact of climate change in the oceans. This project will also contribute to the expansion of Indonesia scientific research at the national and international levels. So now a project which has been ended in 2017, the Indeso Project, which contributed to the long-term protection and sustainable management of marine resources and marine habitats in Indonesia, but also who contributed to the prevention of climate change risks through real-time satellite monitoring of data. This project also permitted to reduce illegal fishing in the Indonesian waters. So now a different kind of project which is supported by IFD, it's a project with NGOs, the Palu Projects. So maybe you know that in 2018, there have been a tsunami in the Palu Bay and all its fishing community have been affected. And after the emergency response by the government, to this tsunami, IFD, to continue helping the population, has mobilized a special grant resource dedicated to the recovery of the fishing sector of this zone. So the project is executed by two NGOs, the CCFDTS, a French NGO, in a partnership with Chiara, an NGO, an Indonesian NGO, and it aims to replace more than 600 boats, small boats for fishing, for fishermen, and will plant more than 100,000 tree mangroves. At this moment, until now, until the date of today, more than 400 boats and 300 engines have been supplied to the fishermen. Some activities, such as training community to react in case of a new disaster or replant mangroves, notably, have been postponed because of the current situation. We hope for sure they will be implemented next year. And as well, a comic strip and an awareness film are planned for the year 2022. So now this is a project under development. So it's currently ongoing. The beginning of the project is currently ongoing now. So it's the Outer Ring Fishing Port Development Project with the Ministry of Maritime Affairs and Fisheries. So this project has as main objective to upgrade 4 Indonesian fishing ports for more performance and sustainability, as a part as well of an eco-certification process based on the ISO standards. So this project is under development, as I told you, and has 4 main objectives. We can name managing the environmental and climatic impact, an issue of each of the 4 ports, but also improve sanitary quality, traceability, and added value of fisheries products, as well as resources management system. So basically is to fish less but more, fish more but better, fish less but better, it's okay. And as well is to create the foundations of a more inclusive port governance. So last but not least is the project with ARD and CLS that I won't spend more time on it because all of my colleagues after will talk to you about it. So then to finish, as we wanted to go further on all these topics, IFD joined multilateral initiatives also, where Indonesia is involved. They permit to have a bigger impact to support specific ocean-related projects. So I can name the Clean Ocean Initiative, but also the Blue Action Fund or the Pro Blue Trust Fund. So in conclusion, at the IFD, as you can maybe see, we are very proud to support all of these initiatives in Indonesia, and we will continue to support the blue economy in this country in order to contribute to its economic and social development, but also to preserve its natural resources and to continue fighting against climate change. Thank you very much.
All right, thank you very much, Leah. Very nice and very in time. So we can keep, I see that 2 people raise their hand, so maybe I ask them to put their question on the little window called question and response, or ouvrir une question, and we can discuss at the end of the presentation on these questions. All right. So next speaker will be Rini Ramanya from local institution in Indonesia. Rini, can you hear me and send your presentation on the sharing screen?
Yes, loud and clear. Wait.
All right.
I will start to share my screen.
Yes, we see you in full screen now. We need to see your presentation. Yes. All right. Maybe.
Is it okay?
Yes, but you have to come back on the first one. Yes, excellent. So I give you your time and your 20 minutes to present your work, please.
Okay, thank you very much, Dr. Maes. Good afternoon, everybody. In this nice opportunity, I would like to present research activities regarding recent status, gaps, and potential follow-up of marine debris research in coastal and small islands of Indonesia on behalf of my college at Agency for Marine and Fisheries Research and Human Resources. Plastic is an affordable, easy to be formed, and durable material. This is why the use of plastic is increasing rapidly 20 times higher since its first introduction in 1960 and estimated over 350 million tons production in 2014. Unfortunately, the advantage of plastic material were applied for single-use product, which led to the increasing of plastic waste. Publication from Jambek et al. In 2016 stated that Indonesia was the second largest contributor of marine plastic litter in the world after China. It is approximately about 1.29 million metric ton annually. This was worsened by the increase in plastic single-use plastic medical waste during the corona pandemic time nowadays, such as masks, gloves, sanitizer bottles, and others. If the trend remains like this and no significant action to tackle this issue, then it is afraid in 2050 there will be more waste than fish in the ocean. Now let's have a look in Indonesia, where around 60% of its territory is marine area. As we can see in table in the left, Indonesia is one of the world's richest nations in terms of its biodiversity. Indonesia is an archipelago made up of about 16,000 islands throughout, which there are unique ecosystems containing a large number of diverse species. Based on presidential regulations number 83, 2018, Ministry of Marine Affairs and Fisheries is given the mandate to monitor and actively involve in developing national strategic plan in tackling the marine debris issue. Land-based marine debris combined with sea-based marine debris from vessel, ghost net, or dumping from shipping lane will end up in water column, sediment, small island, fishes, and shallow water habitat like coral reef, seagrass, and also mangrove. Now, it is not only illegal, unreported, and unregulated fishing that threatening ecosystem and marine biota in Indonesia, but also the plastic waste issue. That is why marine debris research is highly important to address marine debris and IUU fishing issues and supporting the protections of Indonesia biodiversity. Now we are going to see the thematic marine debris research on modeling and dispersal pattern. In this slide, I provide three cases about microplastic trajectories and also microplastics in three different locations in Jakarta Bay, Banten, and Bali Strait. As you can see in this slide, that the results in general indicate that marine debris are moving away from its origin, drifted by wind and current from time to time. In the left side and also here in the middle and also in the right side. The important point to be highlighted is the marine debris issue or problem is not only one sectoral or one region problems because by the effects of wind and surface of the oceans, it can be drifted along the area and then causing problems under two different regions. That is why it is really important to improve the collaborations between two region that is really in neighborhood and also the surrounding area or ecosystems because it is not only the marine debris waste, it's not only static, but they are moving passively by oceans, wave, and wind. So the results of these simulations will forecast the time and place where the marine debris is going to traverse and will be piled up in each season. And this will be helpful for the planning of mitigations and action plans to address. So the marine debris in the regions will be tackled more efficiently and effectively. The gaps with these studies nowadays is there are only local-based simulation and centralized around Java Islands or Bali Islands. So For follow-up research, we want to scale up this pilot project into a regional level that is also consisting Indonesia in um, national level, so that we can see from time to time where to mitigate or to monitor marine debris uh, uh, ended up in which location, so we can provide or prepare for the best scenario to come. Uh, so as I said before, that it is really important to advancing research in marine debris drifter to validate our models that is existing right now. And now we have an ongoing project between French and Indonesia to release some drifters. So the simulations using track drifter have been conducted in several places in Indonesia, where the first marine debris drifter has been deployed in February 7 from Cisadane River. The output of this simulation will enhance recommendations for cost-effective cleanup actions from those identified and verified sea marine litter hotspots. And the Ministry of Maritime Affairs and Fisheries should have a spatial and statistical view of the marine debris hotspot at sea generated from a number of the most polluted rivers in Indonesia or land-based marine debris. Uh, we hope that this project can improve our understanding of marine debris movement and its distribution patterns at sea in order to optimize the action plans and encouraging further suitable marine debris research in certain areas in Indonesia. I won't go into detail the techniques of these drifters. I believe will be presented in much more detail with the next presenter. Now let's move to the thematic marine debris islands. In the left is the research by the SeaCleaners research stations based in Bali, part of Ministry of Marine Affairs and Fisheries also. And they were monitoring the degradations of ecosystem in Lembeh Island, a small island in North Sulawesi, that designated as one of marine tourism site in Indonesia. Based on ocean current patterns, piles of marine debris are moving based on the season. During the east monsoon, marine debris are piled up in the southern part of Lembe Island, while in the west monsoon, marine debris are stranded in the north of the Lembe Island. And from two maps, we can see that the distributions of the marine debris are located near the seagrass ecosystems. So, however, the origin of these marine debris in this island is not yet explored. Whether there is connections between marine debris or tourism activities, it is need to be studied further. On the right side, another marine debris research in small island associated with tourism in the study. The magnitude and tourist perceptions of marine debris on small island tourism in Tidung Islands, Jakarta, were assessed. And the result show that tourism is one of the largest waste generating source, and plastic waste form the major proportion of the solid waste, accounting for over than 80% of the total. The unmanaged tourism waste led to a clean coastal index corresponding to this category, extremely dirty, and can decreasing visitors acceptance index. The resulting conditions will make the tourism unsustainable. In tourism, waste management should be focused on including also prevention and collaborative actions with residents and tourism actors. In addition, the tourist awareness campaign must be conducted prior to tourist visitations on the islands. Now we come to see the thematic marine debris research in estuary area. So this pilot site is conducted by some of my colleagues in Marine Research Center. The area of interest is in Muara Gembong, Bekasi, in West Java Province. So in this area, in the estuary area, marine debris found in mangrove ecosystems, as you can see in the picture. And the most common materials were plastic and rubber, indicated by the blue colors by chart in all stations. The accumulations of marine debris in mangrove areas is a threat to the preservation of mangrove ecosystems because marine debris can inhibit mangrove growth. For follow-up of this research is the existence of marine debris in estuary with mangrove area should be explored further due to the importance of mangrove area as a spawning ground, feeding ground, and also nursery ground for fish juvenile. And because disturbance of mangrove habitat will affecting other associate biota. And we also encourage further thematic marine debris research on shallow water habitat in coastal area, such as seagrass, seaweed, and coral reef. Uh, this one is the thematic marine debris research associated with capture fisheries. So in the left side, we can see the study that examined the value chains of a trawl net, either semi-demersal or shrimps, made in Indonesia using polyethylene material from South Korea, then used by registered fishing vessels operated in Arafura Sea, sized over 200 tons in weight. The results of the questionnaires survey show that all skippers ever experience in losing net, but at a low frequency with the measures, with the majority about 70%, losing them less than once every 5 years. And all losses were caused by snagging on the seabed and non-reported other causes. So based on this research, we can see that the fishing gears, abandoned fishing gears is also becomes a new threat for the marine from plastic materials. And in the right side, we can see that this is the research on the safety of fishery product from organic pollutant and marine debris from the microplastics. This is conducted by the Research Center for Marine and Fisheries Product Processing and Biotechnology under the MOMAF. The results show that the microplastic concentrations on sediment in Jakarta Bay reach up to 380 particles per kilograms, while in surrounding rivers, up to 410 particles per kilo. And another interesting result is the microplastic concentration found in green shells captured in Jakarta Bay are up to 50 particles per individu, while in the feces, up to 20 particles individuals. So for the follow-up, ocean-based marine debris associated with capture fisheries and impact on marine biota, as well as recommendations on appropriate used net handling process need to be broadened across Indonesian water. This is another research from Center for Marine and Fisheries Product Processing and Biotechnology. They are begin to develop a research that using the gracilaria, that is a raw material that is really abundant in Indonesia. We can find the species in naturals, and also now it is also in many areas in Indonesia. So besides gracilaria, the raw materials, we can also use the jelly, or we can say agar-agar in Indonesia. Because jelly producer or the manufacturers is a lot in Indonesia right now. So this jelly is used for a base material for producing the bioplastic ore. For further prototype or the next level research, they have a plan to produce plastic sheets and a plastic bowl. The gaps right now for this research cost is considerable expensive. So for follow-up research, better processing equipment is required to increase productivity and efficiency. Hence, the production cost can be reduced. For thematic marine research, marine debris research for waste handling in small islands, also conducted by some researcher from Marine Research Center. Um by developing a concept, a draft for developing the incinerator vessel. The reasoning behind the research for developing this incinerator vessel is the first one is existing waste collecting vessel operated by local government in Seribu Island are inefficient due to high fuel consumption. And then these vessels are collecting waste from populated island, then transported to an island. Uh, Here is to Pramuka and Pagang Islands to be incinerated there, hence causing air pollution to local inhabitants. And the important reasonings is another important reasonings is there are thousands of small islands that have similar conditions as Seribu Islands like this scattered across Indonesia. Therefore, this incinerator vessel will become solution for small islands in processing their waste, as it could diminish landfills requirements and pollutions with less fuel consumptions. So, follow-up for this research is to design um, is to scale up this design into the prototyping phase. So, besides the research that is have been conducted by our researcher, we also maintain regional cooperations among APEC countries to share common problems and promote joint regional monitoring programs on marine debris. This year, early of this year, on February, we have held the capacity building on global marine debris monitoring and modeling to support protections of the marine environments. So this workshop attended by 60 people, and the participant comes from 9 APEC economies. And the follow-up of this event is to realize the global collaborations worldwide to tackle marine debris issue. So what next? Indonesia is a vast archipelago. The number of published marine debris research in Indonesia remains low. Current marine debris research seems to be concentrated near major cities such as Medan, Jakarta, Denpasar, Makassar, and Ambon within intertidal zone. In the future, research activities should be broadened up until reaching outer small islands in Indonesia, and also encouraging to conduct more studies on marine debris in deep sea zone. Hence, this requires a good cooperations across sectors in local, regional, national, and international levels to tackle this issue. So I believe I have come to the end of my presentation. So questions and critics, suggestions is mostly welcome. And back to you, Dr. Mais.
All right, thank you very much, Rini. It was very nice. And we have still maybe 1 or 2 minutes. Is anyone have a question, a specific question, or maybe I can ask? I'm not sure I fully understand what will be your priorities for the small islands. It's more a monitoring, or it's more an effort in the collecting?
Now, we do both of this plan. We monitoring and then collecting waste also. And we are waiting the results from the our project with French to to prioritize which area to be prioritized first based on the result of the marine debris seasonal pattern. And for now, for this year and next year, we concentrate our research on estuary, especially mangrove area and also small islands, to develop a circular economies based on waste founded nearby the coastal.
Okay, so it's a nice introduction for our next speaker, because we will go now on some idea about the mapping, the connectivity for the major rivers in Indonesia. I'm sure we can find some complement between this research. So if you can remove your sharing screen.
Sorry.
And remember, I see like people begin to start question on the little application dedicated, so it's very nice. I keep the question for the discussion at the end. Don't be, I do not forget your question, but just put at the end. So now we have Delphine who will work at IRD Labs here with me and the group, and she will present our results for mapping connectivity of the major rivers. Delphine?
Yes.
You?
Hi, everybody. My name is Delphine Dobler, and I'm working at the Institute of Research for Development in the LOPS laboratory with Dr. Maes and Dr. Martinez. And I am interested in physical processes of accumulation and dispersion in the ocean. Today, I'm presenting you mapping the connectivity of the major rivers in Indonesia, a Lagrangian point of view. We aim at understanding the beaching patterns coming from Indonesian rivers. And we want to understand this through a numerical experiment and through a statistical point of view. The illustration in the middle is an example of our numerical outputs showing some numerical beaching of fictive particles. And I will explain in the presentation here how we arrived at this map. And the two photos on the left and the right are showing some real beaching marine debris with plastic packages and also fishing lines in Lambangan Island in Indonesia, but also here in France, just close to here in Plougonflan. So the objectives of this project is first to identify the accumulation and dispersion in the open sea. And second, to identify the beaching location of marine debris and the connection with the river sources. For that, we use a Lagrangian adduction of fictive particles in an ocean model. And we are using our homemade Lagrangian software, Ariane, but also surface currents from Mercator Ocean and distributed by the Copernicus Marine Service System. We have, so I said, a probabilistic approach by the release of 2 million of particles during 4 years of simulations. So first, to have an idea of the particles, fictive particles trajectories, we have to input some currents. And we think that we need to consider total currents, meaning that we use the CMM surface merged ocean currents product, smoke product, which is with a spatial resolution of 1/12 degrees and which has an hourly output. And this product includes an ocean global circulation model outputs with tides from the first 2014 tides product, and which also includes Stokes drifts from the Meteor France wave model. These three products are put all together on the same spatio-temporal grid. There is a big importance of processes of different temporal scales in the marine debris accumulation and dispersion, with seasonal variability with the monsoon to daily, monthly variability with tides and waves. And that is the reason why we chose to use this product, which is as complete as possible up to now. Now that we have the currents to transport our fictive particles, we need to define where to put these particles. And we focus on marine debris coming from inland west, and which enters the ocean mainly through the rivers, as explained by Lebreton et al. In 2017. And we decided on a selection of 21 rivers in Indonesia upon 3 main criteria. The first one was an identification of local river pollution by the Ministry of Maritime Affairs and Fisheries, KKP, and the Ocean Cleanup non-governmental organization. But also we had a criteria on high population density, thanks to the NASA SEDAC product, or high river discharge using the Copernicus Glofa system. And so basically this is where the 21 rivers are. So we have 9 rivers on Java Island and Bali, which is, well, as expected, can be expected. But also we have rivers on the Sumatra, Kalimantan, Sulawesi, Maluku, and also Papua region. So we try to cover the whole Indonesian region. Now that we know where to put or to release our fictive particles in space, we also have to understand how to release these particles in the timeline. And for that, we thought that we should follow the river discharges because, well, when river have high discharges, then there is this is most probable that some materials will enter the ocean when there are lots of rain and discharge from rivers. So we have a daily release of numerical particles that follows the discharge of rivers. Here is a plot of the time evolution of fictive particles release, which is between 500 and 2,500 particles every day. We have separated the rivers from Java and Bali in orange color to the other rivers input, just to emphasize the fact that in Java and Bali rivers, the dry season is quite marked, and there are some difference between these rivers, which are located geographically in different locations. Now that we have occurrence, that we know where to put and when to put a fictive particle in our simulation, we are so interested in beachings, and so we now have to have a numerical definition of the beaching, because in the numerical simulation, the coast is, well, as presented in the plot that's on the right. So this is our grid. Each square is 9 kilometers in width, and the currents are computed on this grid. And what you see basically here is the shape of the Sunda Straits in the numerical simulation. So we decided to define the coast as a numerical coast to stay consistent with the current computation, and we defined we chose a simple definition for the beachings, which is, well, when the particle comes between the red line and the black shape of the coast, then the particle is considered as beach. And this threshold, the chosen threshold for the red line, is 10 meters. Well, this threshold has to be chosen far below the width of straits in Indonesia, which are, as you can see in this simulation, like only 2 grid cells width. So now we have the definition for the beaching. And we also define several zones of beaching because we want to understand the different patterns of beaching depending on the area. And so we have defined 42 zones of beachings which has geographical and political limits. So political limits because these are different countries, but also geographical because, as for instance, Kalimantan has 2 zones, one on the Makassar Straits and one on the Java Sea. So now I'm presenting you the results of our simulation. So we computed the trajectories of the 2 million of particles emanating from the 21 river sources. And this is a computation of the number of the average number of particles in each grid cell during the last year of the simulation. This is basically a 4-year simulation. So we waited until the last year. So as you can see, the particles are inseminating the whole region in a band between 15 south and 10 north. And we have 10% of particles that stay at sea. And we have also 30% that go out of regional domain, 26% through the Indian and 4% through the Pacific. And out of our 2 million of particles, 60% of them beached. And now I will just concentrate on this 60% and try to find all the patterns of these beachings. So this is the next slide. First, we wanted to understand the timeliness of the beachings. And so what you see here is the number of beached particles through the timeline. And what we see several information. The first one is that particles are beaching all time of year, but there exist 2 seasonal peaks centered around January, February, and centered around June and July. We also see that particles from all 21 rivers are beaching in different proportions. So here in the parentheses, you have the proportion of particles that are coming, that are beachings and that are coming from the different rivers, from 2% for the Delhi River to 6% to Ambon River. But they stay in the same figures. It's not too far away. And if we are looking at the spatial distribution of this beaching, we found that 92% was beaching on Indonesian coast. So the beachings are mainly local. And what you see on the bottom left is a plot of the beachings counts. So you see the color, green is below 10 and red, the red is above 1,000 fictive particle in one coastal grid cell. Now, but we understand that the beachings are occurring quite close from the river source. We want to have a better illustration of that. And so we did this histogram that is read like this, is that the black line, well, it's a computation of the distance from the river source to the zone of beachings for all rivers and all zones of beachings and all particles, of course. And we computed the amount of particles that is beaching below a distance, a certain distance. So for instance, the red arrows show that 76% of beachings are located within 1,000 kilometers of the river source. So 1,000 kilometers is approximately the Java Island length. And we see also that there are some difference between rivers because we see on the dashed line that Georgia and Palaban Ratu River, which are both on South Java, beaching much more close to the river source than the other rivers. And we also saw that 84% of particles, the beaches, before 6 months. Now, as I said, there are differences on depending on the zones. And for instance, this is an extraction for the North Java zone, so it's particular of interest here. And what we see is that the pollution or the beachings are mainly coming from local rivers, because all the 6 rivers that are contributing to the beachings with more than 3% are located on North Java. And this is quite fast with the regional behavior in time, meaning that the peaks, the seasonal peaks, are around January, February, and around June and July. But if we take now, for instance, West Sumatra, we have, of course, a local pollution with the Batang Kandis River, but also some remote rivers which are contributing with Talo, which is normally on Sulawesi, and which particles come to West Sumatra as well. And in time, this is quite defaced with regional behavior, slightly defaced with regional behavior, because now the peak season is more centered around December. So the preliminary conclusions of this study and the perspectives. We saw in this study that numerical beachings or beachings of fictive particles occur close from the river source in space, 76% below 1,000 kilometers, and in time, 84% before 6 months. They have a marked seasonality linked to the monsoonal signal and to river discharges, and they show variations depending on the considered subzone of beaching. A report with these results, including a beaching atlas by subzone, is in preparation. And we have also still open questions and perspectives. So the first question is the grid resolution impact, because as you saw, narrow straits are only simulated by 2 grid cells, which is really small. And we have a 5-kilometer resolution modelization ongoing, thanks to Lagos. We'll see what the impact with a finer resolution. We also have to answer what is the impact of physical processes interaction, because for the moment we have only added tides and stock drifts to the main output of the ocean global circulation model outputs. And so we miss all the interactions. And we have soon a tight coupled modelization ongoing. So we will see what is the effect of this also. And the last question is the regional versus global model, because as we saw that 30% of the particles leave our regional model, and so we want to know what is the remote fate of these particles. Thank you for your attention. That's it. If you have any question.
All right, thank you, Delphine. So quite on time. So if we have one question from the panelist group, for example, anyone? I still see that a lot of questions are coming on the little window dedicated for the questions, but seems to be more on the presentation by Rini. I see one about the status of the particle. Delphine, can you just say that when they are beached, they stay like that in this state? Is it correct?
The status of the particle? What's the question? Can you?
Once the status for any particle is said as beached, that it remains always like that. Yeah.
In this simulation, it remains beached. In fact, the fine processes on the beach, meaning that particles or mineral debris could come back and forth, is not modelized yet. I mean, we are not in this degree of parameterization yet. So in this simulation, when the particle go below 10 meters from the coast, from the numerical coast, it is set as beach, and it stays in this state. Hope it is clear.
Yes, excellent. So I think it's okay. We can move to the next speaker now. Still waiting for the questions. So next speaker will be Olivia Ansari, and about the trapping microplastics. So now we go more on in situ observations, and with a voice developed by CLS. Who start?
Yes.
Go ahead.
Okay, maybe I will start it, Olivia? Yes, okay. Okay, so hello, good afternoon, everybody, or bonjour, good morning. So yeah, I'm Mulan, as I'm a project manager or project coordinator for marine debris and modeling in Indonesia. Right now I'm with Olivia, which is the engineer for the coastal, and oceanographer from CLS France. So thank you for this opportunity. So for us to present about our project related to marine debris or microplastic waste in Indonesia. So beforehand, I would share about the background of this project. So as we know, Indonesia is among the biggest contributor to marine plastic pollution, and Indonesia government has the plan to reduce plastic waste by 70% between now and 2025. So this project that we will present is a part of the solution to tackle that issue in Indonesia. So without further ado, I and Olivia will start to the first slide. So about I want to share about the introduction of this project. So this project consists with the marine debris tracking and then also and modeling, and also there is a monitoring data center. So this project for the oceanography drift study is to have the understanding the statistical behavior of different kinds of debris, numerous particles and scenarios, but limited by the accuracy of a model. And then we also managed to release of the marine debris like trackers. This is the GNSS tracker or satellite tracker, it's called Margeti, that gives a ground truth with the real drift behaviors or a view number of devices or trackers and one shape of waste represented. So this project is funded or financed by the World Bank and IFD. So we have two stages. Which is the first stage is the initiate phase. It's financed by the World Bank. So we managed to have 20 Margeti or satellite tracker, as well as the initiate study. And then the second phase will be financed by IFD. So the second stage, we will also have around 50 Margeti to be released. So yeah, and then finally, the main user is the KKP or Ministry of Marine Affairs and Fisheries, and then we also having a coordinating Ministry for Maritime Affairs and Ministry of Environment and Forestry. So this is 2 years programs between 2020 until 2021. And then the purpose itself to have a better understanding for better managing and determine accumulation areas of macro waste at sea and onshore. And after we have the simulation as well as the actual drift or in situ measurements, so we comparing the simulation and actual drift, and then we'll improve the model and help to identify statically presence of debris hotspot at sea. So this project is conducted by the CLS as well as the ERD or Institute Development Research. Okay, next slide. Okay, the reverse study. So after we have a lot of discussion with 3 ministries, with the Ministry of Marine Affairs and Fisheries, Coordinating Ministry for Maritime Affairs, as well as Ministry of Environment and Forestry, and finally we conclude three most polluted river and or interesting river to release and to have the modeling, which are Musi River, Cisarane, and Solo. So we have this recommendation studied from Ministry of Marine Affairs and Fisheries, Ocean Cleanup Study, Deltares, and LIPI. Okay, next. So this is this approach, as I mentioned before, about the in-situ approach. So we released the GNSS drifting buoys. Next, Olivia, please. Okay, so as I mentioned before, so we already managed release at first stage funded by World Bank. So we released already 20 margiti from March until October. So at the first trial, we managed to release to Margiti together with KKP, Ministry of Environment, and Kemenkomar. And then the target itself to release 15 another Margiti this year, and 35 Margiti next year, funded by the IFD. So we will doing this project, IFD project with ERD. And then next. So this is some of the picture when we release Margiti with those ministries. And yeah, this is the look of the Margiti of Satellite Tracker. Maybe you can take a look on the picture when we release it. It's quite eye-catching with the yellow color. And then finally we realized that we must cover that satellite tracker with a plastic bag, and then finally we managed to cover it with a black plastic bag. And we put also some logos in the marine debris tracker, which is the logo from 3 ministries that I mentioned before, as well as the contact if the people found this satellite tracker on the land or onshore. Next. Okay, this is the example of the trajectory from the first trial in March in the Cisarane River mouth. At first, Margiti release is going onshore, collected by the fishermen, and then finally we found it, and then we collected back. And the second release, finally we can manage, and we have the trajectory until right now. It's going to the Australian Sea, and then we can also see it on the our web platform or marine debris platform. Next. Okay, so for the study itself, Olivia will share further about it. So I will give the floor to Olivia, please, Olivia.
Thank you, Ulan. Yes, so hello everyone. I'm Olivia. I'm an engineer in oceanography and coastal management, and I did the modeling approach. So besides of the release of drifters, we use modeling to simulate the drift of plastic waste using winds and current forces. So these two approaches are complementary, and we use them to help each other. So to calibrate the simulation tool, we use the actual trajectory of a drifter. This drifter was released in February this year, and we focused on this trajectory during 2 months in the Java Sea, and we tried to reproduce this behavior with our simulating tool. So the colorful lines are the tests that we made by changing some parameters in order to find the best match and to get the closest results. For example, by parameters, I mean the wind and current effect on the object. So this is the results we get. This is a map of all the simulated particles coming from Cisadane river mouth. So the dispersion seems high, but actually this map is in percentage. So every purple circle represents less than 1% of the total amount of particles. So actually all the particles were, well, a majority of them were concentrated on the yellow spots just here. If we zoom in, we can see that most of the plastic simulated was concentrated on a pretty short coastline around Cisadane river mouth itself. About Melalui River, well, the dispersion is very low. 98% of all the simulated particles were grounded very quickly and around the river mouth. So we can assume that the plastic coming from Melalui River stays around Melalui River itself. It's the opposite case for Solo River. Solo is located on the east of Java Island, and the plastic coming from this river, based on our simulations, is spread all over Indonesia, mostly in the Java Sea, but also drifting in the Indian Ocean. So there is no obvious accumulation zone we can get from these maps. So the pattern between rivers are really different, and there is no common accumulation zone between the three rivers we studied. As I told before, the approaches are complementary. The left map is the trajectory of drifters released this summer. So five drifters released in Solo River, and we drifted during 40 days. And on the right is the simulation we did for July of last year from Solo River as well. And there is three conclusions we can make. The first one is that there is no big annual variability. That is to say, from one year to another in July, the behavior is quite similar. Then it validates our results from the simulations. The in-situ data validates the simulations done by our tool. And the third and last conclusion is that the simulation we did can forecast the drift of the drifter. We can predict where the drifter will go. All the information and the conclusion of this project are summarized in a dedicated web platform we developed for the project. So one functionality of this platform is the tracking of all the drifters released at sea. So all the red spots you see are the real-time position of drifters that you can follow. You can also overlay metadata, so currents and winds and tide. And you can visualize simulation from the study. So the results I've shown you before, and you can reproduce it by launching your own customized simulations. So you can choose where to put the source of your plastic waste, the date and the duration to simulate your own drift. I've done with my part. If you like, we want to make a quick conclusion.
So for the conclusion of this project, so we hope that we can, or Indonesian government can also utilize this kind of project to determine of the policies in each region or local government, as well as determination the priorities region which has the plastic waste or the biggest accumulation of the amount of the plastic waste. as well as to optimize the collection program, maybe for each region, maybe collaborated with the NGO or other agency. Yes, I think that's all from us. So if you have the question, you can ask, and thank you for your attention.
Right, thank you, Sari. Thank you, Wulan and Olivia. So maybe I just have a question about the, you have similar project in other regions of the world, and what could be the return rate of your drifter? Do you have an estimation of that?
What do you call the return date?
The return rate is something that you deploy 20 buoys, for example, and you collect by fishermen or because they beach somewhere, and you are able to recollect them. So some kind of return rate that you have experiment in other regions or in other projects similar?
Actually, we experimented in this project since a lot of mortality did beached and grounded pretty fast. So it's not so often that fishermen return the buoys, but most of the time the CLS team came to collect it onshore, or for Musi River, the buoy get collected by military people, so they returned it to the team. But actually, the local people don't return it really often.
All right, thank you. So I see that we have also another technical question that maybe we can answer right now. Someone is asking about what is the buoy, how often does the buoy transmit, and how long can the battery last?
Okay, so the buoy transmit its position every hour. So we have a hourly position and speed of the buoy, and it lasts around 6 months. Each buoy lasts around 6 months duration.
Yeah, it seems to be sufficient to monitor the island and the flux of islands around in Indonesia, for example.
Yeah.
Yeah.
All right. So maybe any other questions? We have a little more time here, a few minutes. Does anyone have a questions for Wulan and Olivia? I see somebody raise his hand. Can you switch on your microphone and ask your question? I'm not sure if the spectators are able to.
No, I don't think so.
Okay, so you have to write your question in any case. It's very special. First time we use this version. Okay, so.
Can I ask something, Christophe?
Yes, go ahead.
Thank you. Thank you for the
Oops.
Oops.
Repeat your question, please. Whoops, no.
Hello?
Yes.
Can you hear me?
Yes,
Yes.
go ahead.
The first question is the same for David and Olivia.
Yeah.
But we don't hear anything.
About the
Okay, so maybe we can move on and just put your question on the dedicated window for the questions and response, and we move to the last presentation for today, and it will be done by Yannick Leroy, which is based on marine plastic pollution as a SeaCleaners organization. Yannick, you are still there?
Yes, I'm still there. Can you hear me?
Yes, it's okay.
Okay, so I will share the presentation.
Yes, please.
Okay.
So for the other panelists, I see that you can also begin to answer the question that you see in the dedicated window if you just say type a response, and you can please, I see that Rini already does that, but other one are also welcome to confirm the response. So Yannick, you can share your screen.
Yeah, I have some trouble to share, but
yeah,
it will come, I guess. Okay, if I take this one.
It's coming. So the
okay, can you see it?
yes, coming soon, a little bit. Maybe you can switch off your video if you prefer. Yeah, it seems to be start. Okay, the floor is yours, Yannick.
Okay, I will switch off the video. Just. Okay. So thanks a lot to the AFD and to the organizing committee for the invitation to give a presentation of our project. So we will present some figures on plastic pollutions and also some projects that we have in order to deal with this marine plastic pollution. So just to introduce myself, as I am the scientific director of this NGO association, the SeaCleaners, and my background is oceanography and chemistry and biology. Okay. So if I go there. Okay, so on the next slide, you can see Yvan Bourgnon. Yvan created the association, the SeaCleaners, 4 years ago now. He's a Franco-Swiss skipper. He started to sail at the age of 8 with his parents for a round trip around the world. And he built a very impressive racing records and with very successful boats. I have a small videos I will try to share with you. Just 2 minutes. I don't know if you hear the sound.
All right, at the moment, I see only a black window. It's coming.
Okay.
It seems to be a little bit slow. But I don't think we get the sound.
Yeah, doesn't matter. So to show you the performance of Yvan Bourgnon during a few minutes on a large sailing boat with his brother. He used to sail very large boats, but at the end of his career, now it's sailing very small boats around the world. You will see it. You can see this is the kind of small boat he used to make a round trip around the world. And he used the same boat to go to the North Pass, close to the North Pole, to link Pacific to Atlantic. Always on the same small boat, small catamaran. This kind of a catamaran, you use them only on beach usually. So, I think, and this is the last race he did. This is a world record on the number of miles on one day, performed on one day. He was with his son, and they performed 400 miles only in 24 hours. Okay, so coming back to the SeaCleaners, so the mission of our association is to commit itself to corrective and preventive actions on land and at sea to reduce plastic pollution. So really the question is why? Why do we see such amount of plastic from time to time at the surface of the ocean? In fact, to answer these questions, we need to look at the figures on plastic productions. You know that the production of plastic started in the 50s, at least at the industrial level. And since the 50s, we produced almost 9 billion tons of plastic around the planet. So it's almost 1 ton per person, because we are almost 9 billion person on the Earth right now. And the question is, when will we double this amount? And you can see the time frame with a good fit for the model. We will double this amount only in 20 years, which is a very small period of time. So why do we have such amount of plastic? In fact, just because the annual production of plastic is increasing always and always. Right now, in 2020, we produce 380 million tons of plastic annually. And there are large investments in the industries in Russia, in China, and other countries in order to increase the number of factories producing plastics. So the trend is really that this annual production will probably double by 30 years. So we'll go up to 760 million tons very quickly. So part of this plastic production is managed, fortunately, but not the entire part. If you see these figures, part of plastic wastes are incinerated, and another part is recycled. It is starting to increase, this part, but still, I would say a minority of wastes are recycled or incinerated. Most part is either going to a dump site, managed dump site, or if it is not managed, it's going to landfill somewhere. So if we sum up the mismanaged plastic waste to the dumped plastic waste in official landfill, you can see that the majority of plastic waste is going to the environment. And a big part of this plastic waste are going to the sea through the rivers. So you all know the impacts of plastics on the animals and the ecosystem. More than 1,400 of marine species are now impacted. More than 1 million birds are killed every year, and more than 100,000 marine mammals are killed every year from these plastic pollution. The problem is that the plastic material was designed since the beginning. And this is very strange when I explain this to people, but the plastic material was designed to last for a very long time. If you come back to the 50s, the main packaging materials was wood, paper, natural fibers, and they used to be attacked by molds, by bacteria, and weathering conditions. And so the development of the plastic material was very nice because it is not attacked by bacteria, it is not attacked by molds, and it takes a very long time to degrade. Unfortunately, at the same time, in the 50s, there was a new economical model just starting. So it started in the US, and this was the model of single-use objects. And the plastic material was perfect because it was very light, very cheap to achieve this goal of this new economy. But we could come back to long-lasting objects. For instance, we say very often that a plastic bottle in PET can last for 500 years. And you can imagine that you could design a bottle of plastic that you can transmit to a new generation over at least 4 or 5 generations, even more. So it's possible with plastic. It's just a matter of how we use it. And the dramatic part of this plastic pollution is that only a small part is staying at the surface of the water. Almost 70% of the plastic pollution in the ocean is sinking to the bottom, and mostly to the bottom of coastal areas. And right now, we don't know the impact on local fisheries and pollution of the ecosystem. So there is an issue about human health, of course. We don't know very well what the extent of this issue. We know that plastic can have physical effects, especially microparticles, chemical effects because of toxics and additives that you can find in plastic formulations, and also biological effects by plastic debris can also be the support for pathogens, viruses or bacteria to be transferred from one part of the ecosystem to another part. So there are two main entry doors by ingestion and of course by inhalation when you breathe the microparticles. So right now we don't know exactly what is the effect on the long term on human health from these plastic particles, and there are many studies ongoing. One thing which is quite sure, and I'm speaking as an ecologist, if there is any impact on the ecosystem, this is sure that we will have an impact on human health. So the impact of plastic waste on climate change, as Christophe said at the beginning, there are more and more papers coming to describe the effect of plastic pollution on the greenhouse gases and the generation of greenhouse gases, and so to induce the climate change. So we don't know exactly all the mechanisms. Some of them were described in literature as reducing the activity of phytoplanktons. So we reduce the potential carbon sink of the ocean water. There is also an issue about the stock of plastic that we have on Earth. From the 9 billion tons that we have right now, about 6 billions are still in the environment. If you do a quick calculation to convert this 6 billion tons, you know that plastic is mostly organic molecules, organic carbon. And if you convert to CO2, this is about 22 gigatons of CO2 stock. And if you compare to the greenhouse gas production that we have every year on Earth, this is the equivalent of 2 years of productions on Earth. So that is to say that fortunately the degradation of plastic is quite slow, but we have a huge stock of greenhouse gas, and we need to understand how we can manage this and really to stop the tap and to stop ensuring this kind to populate the stock. Because these 22 gigatons, by 20 years, if we double the stock of plastic production cumulative, we will probably double this also potential stock of greenhouse gas. And this is really an issue in terms of climate change. So coming back to the importance of Earth and the ocean on Earth, so it covers most part of the Earth. It's nourishing us, it's carbon sink, it's providing oxygen. So it's very important to take care of these oceans. So our missions as the SeaCleaner, the first one is on land to work on stream, upstream, putting people back to the heart of tomorrow's ecological issues, to boost sustainable developments based on circular economy. We strongly believe on circular economy to bring an efficient solution to reduce the plastic waste. And the third bullet on educating and preventing. It's important to educate the people to do the best choice when they buy goods. And it's important to educate also our children to continue to do the best choice. The second part of our missions is really at sea. So we want to raise the awareness of the urgency to collect the plastic at sea because we think it is important to collect them before they sink to the bottom, because at the bottom it would be very difficult to recover the macro debris. And also it's important to collect the plastic before they disintegrate in microplastics, because it will be even more difficult to collect them as on a microplastic. So we also want to provide data, scientific data on plastic pollution, and to develop network and promote scientific studies. So in order to do this, we created an international scientific hub led by the SeaCleaners. This is a kind of a advisory board for us in order to take the right decision in terms of projects and in terms of operational activities. In this board, you know a few names that you probably already know. Christophe just joined the board recently. You can see François Galgani, you can see Denise Hardesty, that you know well, Claire Dufault from CLS Group, that you know, and you can see also Laurent Le Breton from the Ocean and Cleanup. They kindly accepted to help us on the scientific part of our projects. And so I will not go in detail in all the names, but you can see that we have a really good expert from very different field of expertise. So it will help us to set the thematic directions and to provide the strategic advice and the coordination. And also, you will see our main projects is a large boat to collect the plastic, but this boat will also be a platform for scientific missions, similarly to an oceanographic boat. So this is a view of the boat. This boat will be moved thanks to different energy sources, but we want natural energy sources, so the wind, solar panel, and also a fuel engines, but that will be very special because we will have on board a system to collect the plastic and to do pyrolysis of the plastic. And this pyrolysis will generate energy in order to propel the boat. And the way we will organize is to collect the plastic at the surface of the ocean. And there will be a sorting unit in the boat. And if the quality of the plastic is good enough, so we will keep them, store them, in order to feed these materials in a circular loop, in a recycling loop. If the quality is not good enough, it will go to pyrolysis and will be transformed to energy. You can see the way we will collect the plastic you cannot see the belt, but there will be in between, in the middle of the boat. And we will have also trawls in order to have a larger width to collect the plastic. So the size of the boat has a name. This is a Manta boat. And the size is about 56 meters length and 25 meters width. And the collecting width will be about 50 meters. So this boat really will be a platform, a polyvalent platform with a factory on board to collect and treat the plastic, but it will be also a scientific platform and an educational platform, and also a way to teach on circular economy. So this is how we expect to use this large factory boat. We will also have small boats that can reach rivers and low depth areas close to the coast in order to collect the debris. And then the debris can be converted to waste, to energy, or can be integrated in recycling loops. You can see on this slide that we recycling loops will generate resources. I must point it out that these resources will not be for us. There is no economical model. We don't want to sell or to make profit from plastic wastes. In fact, we expect that these plastic wastes will be used by local communities in order to generate some resources and to help to clean or to educate the people. Okay, so where will we go in order to collect the plastic? In fact, we are just beginning to study where are the best spots. And really, for our large boat to operate with a good efficiency, we need to have plastic patches like this one that you can see on the picture. So this patch, the picture was taken in the Caribbean Sea, and you can see in the small map. This is a work performed by a Greek research team on Caribbean islands. It was published recently, and you can see the red spots are the places where there are these huge patches of plastic, sometimes mixed with sargassum, seaweed. And it happens twice a year after heavy rain periods. And if we can find locations like this with large patches, our boat will be very efficient. So in order to select the countries, in order to start collaborations with the different countries, we use the data generated by Laurent Le Breton and his team, on modeling the river input of plastic. And this is the map below. And of course, there are opportunities, as you can see, in Caribbean Sea, but also in Africa, even in Mediterranean, and also in Asia and in Indonesia. So our idea is to start discussing with these countries in order to see if we can help or to be linked to ongoing projects that could help to manage the cleaning of plastic wastes. So the way we are working, we are supported by private funding, mostly, I would say 99%. We are linked to a major institutional partner, like large aquariums, the Monaco Foundation, and of course the United Nations. We are accredited observer of the United Nations. And we have also partnership with CCI France. So Yvan Bourgnon is very active in trying to promote the association, the SeaCleaners, and recently we have many awards from different organizations, and recently we had an award from the ICC International for our project. So in conclusion, the oceans are in danger, and it's important to try to protect them. So we think that the plastic pollution can be fought, and we have the capability to do that. And the Manta project of the SeaCleaners can provide a complete and a concrete answer to these problems. So by ourselves and with a single boat, we cannot answer all the problems, but we want to promote or to stimulate, in fact, people to try to consider the way we approach the plastic pollutions and to get rid of the problem. Thank you very much for your time, and I'll be very happy to answer any questions.
All right, thank you, Yannick. We have closed down presentation for this morning now, and I will open questions, and maybe I will start by Yannick because you are here. And just miss, what is your agenda for the Manta vessel? And also the question, of course, will be related to our public today. What is your expectation with the problem of marine litter in Indonesia?
Okay. Yeah, very good question. Right now, we are almost on target compared to our roadmap. So the first part was to design the boat and to make some preliminary studies. And we are at the end of this. So right now we are starting to negotiating the contract with the shipyard to start the building of the boat. And so the building will start next year. And we expect by 2023, the boat will be available for the first test and available for the first missions. So this is our roadmap. For the small boats that you see, they will be available sooner, probably early next year, because we are using existing boat that we modify slightly. So to answer to the second question, so what do we expect from the from Indonesian country is to try to establish the first link and to discuss and to see how we can the Manta project can fit or not to existing projects to reduce the plastic litter in Indonesia. I already saw that there are plenty of small boats circulating and collecting plastic close to the coast. So how can we bring some solutions that will be helpful for you and how we could work together in the near future? So this is an open question and open discussion.
All right, thank you. Any question from the panelist group to colleagues between you? Maybe I can ask your point of view or your opinion about one question that I see. It's about what are the main challenges if we might face in the future if marine pollution continues? And we can almost be sure that it will continue, and especially the amount going to the ocean will still going up. And what are for you the main challenges? We want to start about this question.
Maybe I can give a feeling.
Yes.
I think the challenge, really, when you see this production of plastic curve, in fact, the production facility are increasing much faster than the facilities to recycle and to treat the plastic waste. And this is really an issue. So really, we need to slow down this increase of plastic production capabilities. And one way is really circular economy and really to think to the material, a longer lifetime, less single-use plastic, but really to work together with producers and decision makers. And also the consumer, I think, has also a power because he can decide if he buy such good or another good according to the plastic content and the type of plastic. So it's important to work upstream as well as to perform cleaning actions, to me.
Yes, probably it's a very complex problem that we have to attack by different phases. So maybe we can go back on more local aspect, and I see a question about the tourism and the activity of collecting on the beaches. And the person asks if there are research in this project to provide understanding to people who live around the beach to manage their trash. And probably the question is more for Rini. What's your feeling about this aspect of the problem? Rini, do you get the questions? You need to mute on.
Hello.
Yes, go ahead. Try to start slowly, please. We are not hearing you. I do not arrive to hear you at the moment. So maybe we can ask another question, but it's related also to the Indonesian action about how the Indonesian government takes the issue about transboundary marine debris. And as you can see in the Delphine presentation, we have some part of the particles in models will leave the waters from Indonesia, of course, and move to different regions of the world. And this subject of transboundaries seems to be a high priority for organizations like ONU and so on. But and the question was completed by, it is possible to tackle this issue from modeling approach? So maybe Delphine, you can say a few words about that?
Yes, I can. Well, first we have to make sure when this is transboundaries and modeling is at stake that we have to compare our modeling outputs with observations first, because, as you said, Christophe, this is a model, and we have some limitation due to the models. So before pointing a finger at other countries or looking for who's responsible for this or for that, we have to have an assessment of the modelization truthness, and for this we need to compare with real observations. So that is a step of the modelization validation that we have to go to now, and to compare with field observations, and there is a high need of intercomparable field observation, I mean normalized observation. So I don't know if in Indonesia there is common processes when field observation is at stake on the beaches or not. But this would be the next step, is really the validation of the modelization before using it for transboundary, for tackling the problem of transboundaries beaching marine litter.
Yeah, sure. And we need also long time series. And at the moment, everybody is still working with only a few years of data of currents, for example. So we need probably some, to answer completely the question, to go on very long time series of dispersion.
Yeah.
And I see another question, maybe you can start a discussion around that. It's how we can prevent the spread of plastic pollution in the ocean. So I think that we all agree on the idea that we need to make some kind of solution to make depollution at sea, but can we prevent the spread of this? So maybe, Olivia, can you say a word about the dispersion of the drifters? Did you see an internal kind of dispersion, or does the drifters are deployed at the same time remains relatively coherent and they have a trajectory which may say that we can collect, or may give some hopes that we can collect the wastes at sea?
Unfortunately, no. This will not be really optimistic about the drifters. They mostly took several paths, and a lot of them grounded, which gives a chance in the case of plastic to collect it on shore. But also a lot of drifters drift for long times, and in the Indian Ocean and in the Java Sea. And some of them took the same path, but mostly there was diverse trajectories and issues with the drifters.
But can we, are we able to estimate the time of dispersion or some kind of, you know, time of before the relative dispersion of the drifter, or maybe it's just due to the fact that we do not deploy enough drifters?
I think it's really dependent on the rivers. For Cisadane or Musi rivers, we can predict, and the drifters had a quite similar behavior, but in the case of Solo, they dispersed more rapidly and took ways more apart from each other. So it really depends on the river you study.
So it makes sense that we need to almost study all the rivers, or I mean the major rivers of Indonesia.
I think so, yeah. And the Ocean Cleanup Foundation and the papers, the literature gives some aspect about the rivers with the bigger amount of plastic. So maybe focus on this one. And we know that Cisadane is one of the most polluting rivers, and start with the biggest one. Yeah.
Yeah, makes sense. So maybe Rini, can you hear us and try to connect you? It's still not working. No. Seems that we do not have to have the sound here. Well, sorry, Rini, we don't really hear you here. So it seems the connection, the video is good, but the sound, try to cut off your video maybe and just try to speak. No, I have nothing. So maybe before to conclude and to finish, I will thanks all presenters, all people involved for today, all panelists, and also all the people who follow us during this presentation. And I think that you still may contact us by emails, and just to have some, if you have some questions, of course, but also if you want to start some discussions about concrete project or more modeling project. And maybe I will stop there and wish you a nice day for all the people. And thanks again. And I also want to thank Kevin, which has been helped us a lot for the organization of the webinar for today. Thank you to all and have a nice day.
Thank you. Merci. Au
Very
revoir.
much. Thank you,
Thank
Christophe.
you. Bye.
Bye.
Thank you. Bye.
Thank you. Bye.
Bye.
Bye.